All of the examples we've looked at so far work by taking multiple rows and squishing them down into summary rows. And they all use group by to do that. What if you want to keep the original set of rows, but you want to add some aggregated information to each row? So for example, let me start with select top 50 star from names, from the all data table of names. And I'm not going to order by anything just yet. So here's the top 50 rows by all data. And let's go ahead and start with the name Mark. And I'm going to use MARK because it's a more common name. So here are the rows for Mark, and I have name count, name, metaphone, year, and gender. So let's go ahead and just select those rows. And I'm going to start with name, and then we'll do, actually let me start with year first, then name, then gender, and then we'll do name count. And then I'm going to order by. Let's do gender first, and then year, and that should be enough. So what I have is for 1915 through 2014, all of the records where females were given the name Mark. And let me get rid of this top 50. Okay, so now I have all of the females from 1915 through 2014, followed by all of the males from 1915 through 2014, along with the name count. But one thing that would be handy is to be able to see not only the name count for females, but the name count total. So for both males and females in 1915. So this is kind of an aggregate value because I have to combine the value here in this row with the value here in that row. So I want to aggregate those two values and display that as a column along with each row. So the way to do that in SQL is using something called a windowed function. And a windowed function is going to look like this. So I want to sum a set of values across multiple rows, and I want to sum the values in name count. And then I specify where the rest of the values should come from. So over, and then partition by. And what I want to specify is all the other rows that have the same name and year. But then I want to sort of ignore gender. So I want to aggregate based on gender. So I'm going to partition by just year and name, and that's going to sort of aggregate all the gender values. So year, comma, name, and that's going to be as total across all genders. So same year and same name as the current row, but I'm going to aggregate values for different genders. And here's what I get. So now the total across all genders is 544, which is 15 plus 529. So 15 plus 529 is 544. And you'll notice I get the same value here, 544, as I get here. And that's because when you ignore the gender, when you aggregate across gender, both of these rows are the same. They have the same year, same name, so I get the same value here. Now, I can also use this value inside of a calculation in the select clause. So for example, I can calculate 100 times and then I can say name count. So that's the total number of names for this gender. And then I can divide that by this whole expression. And that's going to give me as percent of babies with this gender. So basically, we see that in 1915, 2.75% of babies named Mark were female. And if I scroll down to the males, we see that 97.2% of babies named Mark in 1915 were male. Just to clear this up a little bit, I don't want all this precision, so I'm going to use stir to format these results. And I'm going to do 4 wide, actually, so maximum is 100, so 100 is 3 characters, a dot is 4 characters, and then I'm going to take 1 decimal place, so that's 5 characters total with 1 value after the decimal point. Oh, and that actually has to be, this whole thing, this whole expression has to be there. There. So I'm taking the final result and turning that into a string. Great. So 2.8% of babies with this gender versus 97.2% with this gender. Now, I can also use this to sort of get the same effect as I had last week with my complicated join, where I can put both the name count for females and the name count for males. So I'm going to call this as this gender count. And then for the other, it's going to be this expression minus name count as other gender count. And I have a syntax error because I'm missing a comma there. Great. So now we see that 15 with this gender, 529 with the other gender, gives us a total of 544. And then this over that times 100 is 2.8. And same thing down here. 529 plus 15 is 544, 97.2%. So this is actually quite a bit simpler than doing the complex join of the table with itself. But there are some limitations here as well. So I can order by any of these columns, even if they include window functions. So for example, if I want to order by, instead of gender and year, let's order by, let's do other gender, total across all genders. So total across all genders. So this is going to, and let's do it in descending order as well. So this is going to work just fine, even though this column uses a windowed function. So you see I'm in descending order by total across all genders. I see that the peak here was 1960, and then 1961, 1959, 1962. So that was the peak popularity for the name MARK. But I can only use these windowed functions inside of the select clause and inside of the order by. So for example, one thing I can't do is I can't say and total across all genders is greater than 10,000. So this is not going to work. And it's even not going to work if I put the actual function there. So here's the total across all genders, the calculation for that. And I'm not getting a syntax error, but if I try to execute it, windowed functions can only appear in the select or order by clauses. And the reason is because of the order that things happen on. So first, you pull the data from the table, then you do the where part, then you do group by if there is any, then you do having if there is any. Then those results, after all of the filtering and if there's any joins, all that other stuff, only those results actually get the window function applied to them. And then finally the things are ordered and the columns are displayed from the select. So basically the windowed functions happen after all the data is aggregated and grouped and filtered. So I can't use it in where because this value doesn't actually exist until after this where clause is executed. And same thing with having and group by. If I put a group by, I put a having, I can't use the windowed functions in either of those because they don't exist until the very end. Now there's some straightforward ways of getting around that limitation, but they involve subqueries, which we'll be talking about next week. So just take my word for it for now. So I'm going to go ahead and get rid of that clause because it doesn't work. And re-execute the query. And I can also aggregate over different criteria. So here I'm matching all the other rows that have the same year and the same name and creating an aggregate value. So that's going to be any gender but the same year and the same name. I could also do, for example, some name count over partition by name and gender. And so this is going to include the other rows that have the same name and gender, but it's going to ignore year. So it's going to aggregate over year here. So that's going to be total over all years. Let's say across all years. So here, if I execute that, I see that for female babies named Mark in all years 1915 through 2014, there were a total of 44 female babies named Mark. And for male babies named Mark across all years, there were 1.3 million babies named Mark. And you'll notice that I really only have two numbers across all the rows. I have a number for females and a number for males, because that's the only difference between these sets of aggregates, is one is female, one is male. So I've rolled up all the years and all the names and just included one bucket for female, one bucket for male. So what if I want to ignore year entirely and sort of group by name and gender, roll up all of these year values, but then still have a total across all genders? So that's going to be combining a windowed function for the gender counts with group by name and gender. So let's take a look at that. Select, and I'm not going to include year here because I'm going to group all the rows together that have different years. So I don't need to aggregate that. I'll include name and I'll include gender. And then from all data, where name is Mark. And here I'm going to group by name and gender. And let's go ahead and also include name count. Now, name count is going to be an aggregate value that I get by squishing all the years together for this combination of name and gender. I get one row for each combination of name and gender. All the different rows that have the same name and gender are getting squished down into one result. So I have to specify a way of combining name counts, and I'm going to use sum of name count there. So that's going to be total count across all years, like so. So I get one bucket for female, one bucket for male, but now I also want to get the total across both genders. So what am I aggregating here? So I'm going to have fill in the blank here over partition by, and then I just have name to partition on. As total across all genders. So what goes here? Well, if I start with name count, that's not going to do it. Actually, I need a comma here too. So if I start by name count, that's not going to do it. Because this sum name count goes with this group by. And in order to re-aggregate this based on other rows that have the same gender, I need a way of combining those. So basically, I get a sum name count for this row, and I get a sum name count for this row. And I'm trying to combine those two values together because of the way this is partitioned. And I have to specify how those values get combined together. So what I actually need is going to be sum of sum name count. So once again, this first sum name count goes with this group by, and then the second sum goes with this partition by. So if I execute that, I see 4415 plus 1339606 is 1344021. And then I can do the same calculation as I was doing before. So I can say, for example, sum 100 times sum name count divided by sum of sum name count over partition by name. That's going to be percent with this gender. And let's go ahead and use stir stir that whole thing. 5 wide, 1 after the decimal. So this gives me the percent of babies named Mark who were female overall, which is 0.3%, and the percent of babies with the name Mark overall, which was 99.7. So now I can do something, just to close this part out, I can do something that's kind of fun. I'm going to change this to select top 50, and then I'm going to order by the absolute value of this thing minus 50. So what's going on here? This is going to be values that are close to 50, either a little under, a little over, are going to be close to 0 when you subtract 50 off of it. Absolute value is going to make all of those values positive. So basically, the closer you are, either over or under 50, the lower this final number is going to be. And then I'm going to order in ascending order by this. And so the numbers that are closest to 50 are going to float to the top. So this is going to be names that are evenly divided between males and females. Oh, and I don't want to do that part here. Just that part. Okay. So now let me get rid of this where clause. Okay, so these are names that are right at 50. Now you'll notice that I have a problem because, or maybe something that's not desirable, because most of the names that are exactly 50 are relatively small counts. So 5 is like the minimum number that will end up being shown in the census data. And so these are all 10s, 5 female, 5 male. That's not very interesting. What's really interesting is the ones that are really popular names that are equally divided between males and females. So I really want to say something like total across all genders is greater than, 100,000 or 50,000 or something like that. But I can't do that because remember, the where clause and the having clause, they both happen before these values are selected. And so if I try to filter the data, it's going to affect the windows, and basically I'm kind of out of luck. What I can do, though, is I can ignore any rows where the name count is less than a certain number this week, and then next week I'll show you how to fix that problem using subqueries. So for this week, all I'm going to do is I'm going to add a where clause where name count is greater than, say, 10,000, because that's going to be on a year-by-year basis. So this is going to filter out all the data where there are fewer than 10,000 babies registered, and it's going to aggregate the results and then sort them and so on. And I didn't actually... Let's try 5,000. Okay, so that's getting a little better, but still a pretty big split. Let's do 1,000. Okay, so now we have some names. So Quinn is actually a popular name that's pretty evenly split from males and females. Quinn, Riley, Jackie, Carrie, Jamie, Peyton, Jesse, Casey, Angel, Avery, Skylar, Jordan, Leslie, Taylor. So if you're looking for a good popular unisex name for your baby, these are all starting to get lopsided here. Next week when we look at this as a subquery, we're going to get some better results. Let me just drop this down to 100 and run this one last time. Okay, so we got Camden too, Jail, Lauren. Okay, and then unknown. And somewhere in this list, there's probably going to be baby and infant as well. Yeah, so there's infant. I don't know if baby made the list. But the problem here, yeah, so there's baby. This data comes off of birth certificates, and oftentimes if the baby's name hasn't been picked yet, they'll just put baby or infant or unknown on the birth certificate, and so that gets into the census data. And we could look on that as a year by year. So let's actually do that in the next video.